There we go. All right, so today, and pertaining to your home assignment, which I will upload tonight, and you will have until Friday night in order to do. Maybe I can extend it to Saturday, depends on stuff. But yeah, today we're going to see everything that's pertaining to simulation. So some of you guys, for the last assignment, researched some functions called R norm, R uniform, R Poise of Poisson, etc. Now these functions allow you to generate random values from a given distribution. Now, for example, R norm gives you values from a normal distribution. The first argument is how many values you want. Second is the mean. The third is the standard deviation. Now remember, it's the standard deviation. Usually when you write n of mu sigma squared, it's the variance. Over here in R, you have to give it the standard deviation. If I run this, I'm gonna get 15 values that come straight out of a normal distribution. However, if I take out the mean of these values, of this sample of values, I'm getting 15.12. And I said that the mean was supposed to be 15 exactly. Why is this? Is that we are looking at a sample. We're not looking at the population. Okay? Now what happens if I run this again? I get a different set of values, right? If I run this again, I get another different set of values. If we want to get the same results every single time, then we have to set a seed. Seed allows us to replicate results and have the same different output every single time we run this. So for example, if we set the seed at 1 and we run this, look at the vector that we get. If we set the seed at 1 again, and we run this one more time, we get the same set of values. Okay, how can we test this? Let's do something like this. For example, 2. Remember when we saw comparisons, if we do R norm example equal R norm example 2. Oh, I didn't run it. And we get true for all of them. How can we narrow this? We can use the function all, and if all of the values inside here are true, then we're gonna get true. That means that by setting the seed, we replicated the result. Now what happens if instead of 1 we write 2, 3? Are these going to be equal? No. Okay? The number inside the seed matters. Okay? You can choose any number you want. The thing is that you choose one and that you stick with that one. For example, I like to use 42, but that's just me. Now sample. You guys saw sample the last time when you had to do your die and your roles and the fair value, etc. We generate an example vector. And there's two ways of sampling, right? You have without replacement and with replacement. Now, out of this example vector, I want to get 15 values. And I don't want any replacement. What does that mean? That means that if we take one number from here, we cannot choose that number again. Look at the vector, there are no repeating values, okay? What happens if we do sample with replacement? Then we might get the same set of values. So there's 17 over here, 17 over here, 6 over here, 6 over here, okay? Now what happens if we do this operation again? We have a different subset of values. Now, how can we do the same set of values again? By setting a seed. If we run this again, we're gonna get exactly the same set of values. Okay? Your store set seeds? What do you mean? Roy, what do you mean? Alvaro's email just arrived, by the way. No, I still don't understand you, Roy. Well, you can save them in an object if you want. Set over here. We assign them to an object called our normal example 3, our normal example 2, our normal example. I don't know if that answers your question. No, oh, okay. I get your question now. So seed is not an object. So what seed is doing is telling R to start their pseudo-random algorithm in a certain way. And imagine you have a book of random numbers. And what set seed is doing is telling R to start from line number 1 of those random numbers, line number 2 of those random numbers, etc. Is that clear? Okay, awesome. So the law of large numbers, guys. Last time we saw the theory of the law of large numbers. We have mu and a sigma. Now, I don't know if you guys are familiar with the function rep. I told you guys, I told some of you guys how this function worked. We can repeat a value, in this case 0, an amount of times, in this case 50. So by doing this, we create a vector of 0 repeated 50 times. That allows us to save on some memory, okay? Now in the first space, in the first entry of vector of means, we're going to calculate the mean of one value from an R norm with these two sets of parameters. We check this. This should be the mean and still a bunch of zeros. Now we can use a for loop in order to fill out the rest of them. So if we now look at the vector of means, we have a vector of means, and since we have 50, they should be around our 172, right? However, there's a neat way of doing this thing without using a for loop, and it's called replicate. If we do replicate, how many entries we want? We want 50. What do we want to replicate? We want to replicate a function that we're going to create, and that function is mean bar norm of x our mean is mu, or is this sigma. My bad, I created some. Oh, okay. Let's do something like this. So we replicated this function how many times? This one. In order to do exactly the same as before, let's just use one, okay? So we recreated the loop by using the function replicate. What replicate does is that you take a function and it generates that function the amount of times that you tell it to do it. So in this case, we wanted to run that function, that iteration, 50 times. Now, in order to make this more accurate, instead of 1 or instead of I, let's do this X amount of times. Okay, I get this now. Let's do this 50. So by doing 50 amount of times, you get a vector of normals, 50 values straight out from the normal. Yes, hold on, jump here. Yes, I'm going to explain that right now. So you get 50 values from the normal, and you're getting the mean of them. Now, the difference in between this and this, we're changing the I in how many random values we're generating. So this is for illustrative purposes, how replicate works. However, in order to do the law of large numbers, we're going to use the loop because we're changing how many values we're taking out of the distribution. I'll run this again. So you see that on the first vector means we're taking the mean from just one value, then from 2, then from 3, then from 4. Okay, how can we do this without using a loop, a for loop? It's with sapply. Sapply allows you to iterate in between a set of values with the function we want. So in this case, we can write this like this. And we're going to get arguments. Why? trace back. Do I have mute? Yeah. Ah, it's sigma, not S. So in this case, we're replicating the loop by increasing. Now, sapply, what it's doing is taking each of these values. This is a vector from 1 to 50, and then running this function first with the value 1, then with the value 2, then with the value 3, 4, all the way up to 50. Okay? So this is a better way to avoid writing a for loop. Okay, so if we save this in vector means, we can plot this, right? So we want to plot it, our x is going to be 1 to 50, our y values are going to be the vector means. These are the labels for our axis. An AB line allows us to make a simple line. So first we're going to plot our values. Then we plot the true value. Now, this true value, 172, should have been the mean, right? However, when we're increasing how many values we take and we generate from a random distribution, our estimates are closer to the real value. So maybe instead of, let's make it as a variable. So simulations or iters, going to be instead of 50, 10 million. This is iters. This is iters. Iters. I hope this can plot as many points. Maybe 10 million was overkill. Yeah, it's less. So what this is doing is 10,000 times running the same function and getting the means. Now, whenever you're working with 150 values, okay, let's do 150 values. That's right. So you see that it's converging to the 152 value. If you increase this, then it'll be closer, right? Every single time. However, R was not made to, so allow me to correct myself. R was made to, to do this kind of things. These are base plots in R. However, you can use different packages in order to do actual pretty and presentable plots. So we're gonna use a function library in order to call a package. Now that package is going to be ggplot. Now ggplot works with data frames. So we're going to create a data frame. So data frame, like that, data frame. Now let's just be simple and call it x and y. X is 1 to iters, and y is my vector means. So now I have a data frame. This data frame contains the data I want to plot. If we do ggplot, that, and the syntax of ggplot is an object on top of an object connecting them by this plus sign. So I've now told ggplot that I want to use this data. How I want to use this data, I want to do a line, a point maybe. I want to do a point. I have to specify the aesthetics, what is X and what is Y. And that is the only mandatory thing I have to tell it. Now I want something else. I want the true value to be shown as a line, just like this blue line. So this is a horizontal line, so GOH line. What is the y-intercept? This doesn't look that pretty, that fancy. However, we can do more stuff, right? Let's do theme minimal, which I like pretty much. It looks quite better, right? You can investigate, and I will put a lot of material over the course on Tidyverse, which is a family of packages in which ggplot2 is included. You can maybe write a title, simulating the law of large numbers. The title. Simulating the law of large numbers. You can do basically anything on ggplot. And this looks much more presentable than this. Okay. Now let's do the same with a Poisson distribution. So I can generate 100 values of a Poisson distribution with mean 30. If I plot the values, we can see that it really doesn't look around there. However, you can see that it moves around the same value. Now, in this case, I'm not calculating the means of the values. I'm just plotting the values I've extracted from the distribution to see how much close to the distribution they are. Now, to finish this tutorial, we're going to do something fun. So we're going to simulate pi. Now, a really easy way to simulate pi is to create a circle. So we're going to create uniform distributed values. How many? 5,000 from -1. So we're going to do a circle of diameter 1, radius 1, I mean. We're going to create a condition. It will be a logical. If x squared and y squared are less than 1, then that means it's inside the circle, right? So if you see over here, it's a logical value. How do I know if it's actually if what is the number of pi? So how many values inside the circle divided by n multiplied by 4 should give me the number pi? Why? Because of the formula for the area of a circle. If you look at the number of estimate with how many I gave it? 50,000 values, I get 3.1356. And again, we can plot this in the regular way of R. The ones that comply with the condition, I want them to be in red, and the ones that don't, I want to be in black. Let's rearrange this in order for it to look like a circle. Okay. So the numbers inside the circle will look in red, and the numbers outside the circle will look black. Now the thing is, my estimate, even though this circle looks pretty good, my estimate doesn't look that great. I have to increase this. Now this is vectorized, so it will run faster than the other thing. Oh, what it won't run faster is the plotting of the points. However, disregard the plotting of the points. Check out my estimated value on pi. 314.05. That's much closer than what the last estimate was, right? Now we can change again this as a function and write either a replicate or an supply depending on what we want to do. My R froze. Okay, depending on what we want to do. So for example, we can do either these two problems. How the estimate approaches pi, or we can do a Monte Carlo simulation. Now for this one, it's useful to use a supply. For this one, we won't replicate. Let's delete this in order for it not to eat memory. And for both of them, we want to plot them as a ggplot. Okay. Now, once again, this is homework for you guys to do at home. It should be really quick, so it's half the usual point. If you have any doubts or any questions, please care to ask right now. Yes, for everyone. Friday before class. You have to do both, by the way. And you have to use ggplot for plotting. So this should be pretty easy, right? We've done one way over here, and we've done replicate over here. So, just a heads up for the Monte Carlo thing. So on this one, you're estimating the value changing and well growing in how S approaches I. That's basically what you want to do. Now, case using a large N and taking the mean of all the simulations, how close is the value I? This is your tool to plot. And this should be assignment 3, right? Friday, 10:30 a.m. No, it cannot be midnight. Okay, as for emails, in this span of time, another Mauricio's email arrived. And yeah, that's it. Do you have any other question, guys? Just to repeat myself, the take-home part of the test will be uploaded tonight, and it'll probably be either for Friday night or for Saturday night. Yes, I will upload the instruction for the assignment 3 in a sec. What else? When is the next exam? It's on the syllabus, actually. No, it was never going to be Sunday. No. The max I can extend it to is Saturday night. Wow, you guys are begging already? Really? Okay, Saturday it is then. I'm going to change this to Saturday. It's the 25th, I think. Yes. Saturday, 11:59 p.m. Okay, yeah. Do you guys have any questions? Oh, one last thing. For the ones that have sent me like 2, 3, or 4 emails, I suggest you guys to order stuff up and send me 1 email. Also, some of you guys didn't use the correct subject for the email. I may miss your email if it does not have the correct subject. So check that as well. So for everyone that the subject was like test1 and your last name, something like that. Quantitative finance test1 and your last name. So guys, check the instructions on the tests. Yes, the one that Roy put. I have seen the email arriving. That doesn't mean I will see it when I'm grading. It will be useful to send it again. And if you've sent multiple emails, please gather everything up in just one email. It goes for everyone. But yeah, do you guys have any questions? Yes, you can send it again. However, there you cannot make corrections, right? Then just put forward and change the subject. All right. If there are no questions, then class dismissed. I will see you guys on the next Wednesday. Good luck. Yes, the setup can be the same if you want. All right. See you guys next Wednesday. Have a good one.